To expand a binomial using the binomial theorem and Pascal's triangle, I like to use a chart to help organize my work. Now, I will tell you in advance that this is not a short problem. I hesitate to call this a shortcut. However, it's much better than the alternative of multiplying this out by hand. And so I've gone ahead and made my chart. It's always going to have 3 rows in it, and your number of columns will always be 1 more than the power you're raising it to. So for a 6th power like this one, I have 7 columns in my chart. Let's go ahead and fill out the top row of the chart using our numbers from Pascal's triangle. Since I'm raising to the 6th power, I'm going to look at row 6 in my triangle, Pascal's triangle. So checking my notes or going online to find that, I can see that the numbers are 1, 6, 15, 20, and then they drop back down 15, 6, and 1. Hey, look, my chart fits perfectly. You'll know you're in the right row because that second number is your row number. So that's the top row of my chart, Pascal's triangle numbers. Next up, for the middle row, I'm going to take my first term and include parentheses if there's ever more than one piece of it. In this case, it's just A. And you may have noticed from the patterns we talked about in class, that will always start from the highest power, so A to the 6, and then it's going to drop by 1 each time in my chart. So 5, 4, 3, 2, 1, and it's going to end up with a to the 0 power, which is just 1, or I just X out that last space. Okay? And then finally, for the third row of our chart, I'm going to start with my second term and increase in power, starting from nothing though, starting from negative b to the 0. So I always just start with a blank space. Next up, I'm going to include, like I said, parentheses, so that's negative b to the first, and then it's going to increase by 1 each time. So negative b to the second, third, fourth, fifth, and it'll end with the highest power, negative b to the 6th. Okay, so there's my chart filled out. What I'll do then is I'm going to multiply everything in each column together to get each term in my answer. So multiplying all this together, 1a to the 6 is my first term in the expansion. Next up, I've got to multiply this. 6 times a to the 5th times negative b to the 1st. Well, I purposely picked one with negatives because I wanted to talk about what happens. With your parentheses, negative b to the 1st power means this term is going to just be negative. So I'm going to just write negative 6, and then a to the 5th, and then just b, because I've multiplied that negative in front. Compare that to this next piece, negative b in parentheses squared. Well, negative b times negative b is a positive. Basically, what's going to happen is your signs are going to alternate. So if you want to just follow that shortcut, your first sign's always positive, and then negative, and then positive, and then negative, and positive, and negative, and so on. So sometimes I just remember that. Anyway, finishing this up, I've got 15, a to the 4th, b to the 2nd. Notice that in each term, the sum of your exponents is the power. So 4 plus 2 gets me 6. Finishing this out, I'm going to alternate signs. So I'm now negative 20a to the 3rd, b to the 3rd. Then I've got positive 15, a squared, and b to the 4th. 2 terms to go. I'm now at negative 6, a to the 1st, b to the 5th. And then finally, I'm going to end with just b to the 6th. So that whole answer is my expanded polynomial. Like I said, definitely not a short way to do these problems, but it is much shorter than the alternative. And for time, so this video is not too long, I think I'm going to take this problem and do that as a separate video. So if you want to see how this one's going to expand, take a look at the next video.